Okay, today's the last section of Unit 8, and it's 8-6. We're going to be talking about vectors. The speed and direction of an object moves can be represented by a vector. A vector is a quantity that has both length and direction. You can think of a vector as a directed line segment. The vector below may be named AB. A is your initial point, starting point, to the terminal point, okay? And guys, it's not like a segment symbol. Here's your segment symbol. Your vector symbol looks like there, so you can see the difference, okay? So you can name this vector, vector AB, okay? You must start with the initial point as your first variable there, or you can label it vector V. Okay, a vector can also be named using component form. The component form, xy, of a vector lists the horizontal and vertical change from the initial point to the terminal point. All right, guys, this is opposite slope, so do not get it confused, okay? Remember, slope is vertical over horizontal. This is the opposite. All right, so what you do here, this is vector CD, initial point, terminal point. All right, we start at the initial point. We go horizontal, 2 units, vertical, 3. So the component form would be written 2, 3 with your symbols here. So let's write vector HG in component form, okay? So here's my initial, here's my terminal. I go horizontal, 3, and then I go vertical, 5. Okay, and then down here we have vector U. Right here is my initial, right here is my terminal. So I go horizontal. We need to back up on this first one, guys. I went left 3, so this is a left 3. I went up 5, so it's a positive 5. So on this one, I go left 3, and then I went down 4. So you must make sure that you have your positive and negatives correct. Okay, now what we're going to do is we're going to write the vector in component form. All right, so we have vector MN. So here's your initial and your terminating point. So we go from here to here. And what you want to do is you want to look at your horizontal, okay? So for the horizontal, I can take -8. Actually, let's do it the other way. I can take 2 and minus the -8. And for the vertical, -7 minus the 1. So 2 minus -8 is what, 11? And -7 minus 1 is -8. And this is not 11, that is 10. See if I can do my computation right. All right, so then put it in component form. All right, just like finding slope, okay, guys, but instead it's horizontal and vertical. So if you want to label this x1, y1, x2, y2, you take 2 minus the -8, -7 minus the 1. All right, so see if you can do this one on your own. It's giving you the initial point and the terminal point, okay? So you're going to take all right, the magnitude of a vector is its length. The magnitude of a vector is written with your absolute value symbols and how you write the vector inside. Draw the vector -1, 5 on the coordinate plane. Find its magnitude to the nearest tenth. Okay, so the coordinate plane. Start at the origin, and what we did is we went horizontal, -1, up 5. Initial, terminal point. Okay, so we need to find the distance. Okay, so we've got -1, 5 as a point, 0, 0 as a point. No, y'all don't like distance formula, but you need to get used to it. Okay, so we're going to take -1 minus 0, square it, add 5 minus 0, and square. So what do we have here? -1 squared is 1. 5 squared is 25. So we have the square root of 26, and it says round to the nearest tenth. So the length, the magnitude of vector -1, 5 is approximately 5.1. So that's how you would write it. Okay, see if you can do this one on your, whoops. See if you can do this one on your own. Do you really need to graph it? Not necessarily. Just make sure you know which one your points are. Okay, directions of vectors. A direction of a vector is the angle that it makes with the horizontal line. Okay, so we have vector A, B, all right? Here's the horizontal line. So you start from the horizontal line and you measure this angle. The angle is measured counterclockwise from the positive x-axis. The direction of vector AB is 60 degrees. The direction of a vector can also be given as a bearing relative to the compass directions north, south, east, and west. Okay, so we have vector AB right here, and it has a bearing of north 30 degrees east. Okay, so what you do is with your y-axis and x-axis, the positive y-axis is north, the negative is south. The negative x-axis is west, the positive is east, okay? So if we're going north, you want to start right here. And if you're bearing 30 degrees east, the angle is going to be from the positive y-axis. All right, so the force exerted by a skier is given by the vector 1, 4. Draw the vector on the coordinate plane. Find the direction of the vector to the nearest degree. To the nearest degree. Okay, so you graph your vector AB, and if I draw this vertical line and horizontal line makes a right triangle, right? I've got segment AC with 1 unit, segment BC with 4 units. And I'm trying to find, what am I trying to find here? The direction. Okay, so the direction is going to be from your x-axis to your vector. So it's angle A. Angle A is what we're trying to find here. Well, if you notice, we've got a right triangle, and we've got opposite adjacents. So we need to start thinking the tangent of angle A equals 4 over 1. All right, because we're trying to find angle measure, we're going to take the inverse of 4 over 1. So the measure of angle A, rounded to the nearest degree, is 76 degrees. Last one, I'm going to do the same thing, so I'm going to be quiet and let you figure it out. All right, guys, have a good one.